So boys and girls, that's how you find the volume of an object. Length times width times height.
Teacher, but how do we find the volume of an irregular object, and how do we know how close it comes to the actual volume?
I'm glad you asked that. In order to do this, you will need one graduated cylinder, irregular shaped objects such as coins, water,
Data chart.
Fill this graduated cylinder enough so when the coin is placed in, the object will be fully submerged in the water. Also, you must be careful not to put so much water that the water level will rise past the graduated cylinder's markings. You also must make sure to read the meniscus when determining the volume. The meniscus is a curve in the surface of a liquid that is produced in response to the surface of the container. After you have filled the graduated cylinder, record the volume of the water. The data should be marked Data A.
Carefully place the object into the graduated cylinder.
I said carefully. Record this volume as Data B.
To find the volume of the object, we're going to subtract the volume of the water without the object from the volume of the water with the object and record that result in column 3.
In order to calculate the correct volume, we will be performing 3 trials, followed by calculating the percent error of each trial. Let's see how our students do.
Student 1 is measuring the volume of the water without the object. She has concluded that it's at 85 milliliters.
Which I will record on the chart.
Now she will drop the quarter into the graduated cylinder
Carefully.
and record the new volume. She has concluded that it's at 86.6 milliliters. Now student 1 will do the math to determine the volume of her quarter.
.6 is the volume of my coin.
Student 1, don't forget to add milliliters.
That's right. Oops. Gotcha. 2 is now looking at the cylinder, and she's going to find the volume of the water without the object, and she came up with 50 milliliters. Now she's going to carefully place her quarter in the cylinder, and she's going to read the volume of the water with the object, and she notices that the volume now is 52 milliliters. She will now perform the math of the volume of the object. 52 milliliters minus 50 milliliters is 2 milliliters for the volume of the object.
Student 3 is filling up his graduated cylinder, but he has filled it past the markings on the graduated cylinder.
Will this alter his percent error? Student 3 is taking a look at his cylinder to determine the volume of the water without the object. He notices that the volume is 120-ish? Now he will drop his quarter in the cylinder to determine the volume of the water with the object, and he notices the volume is 126 milliliters-ish. Now he will perform the math. The volume of the object is 126 minus 120 is 6 milliliters for the volume of the object-ish. To find the percent error, I will take my result, which is 1.6, minus the accepted value, which the teacher has told us is 1.5. Divide that by the accepted value of 1.5 times 100, because we are dealing with percent, is 6%. 6% error.
In order to find my percent error, I am going to take my result, which is 2 milliliters, minus the accepted value, which is 1.5 milliliters, divided by 1.5 milliliters, times 100. That equals 33%.
To find my percent error, I take 6 minus 1.5, which is our accepted value, divided by 1.5 times 100, which gives me 300% error.
So there you have it, students. Any more questions?